The first question that I'm going to ask you is what does a software development process, what does it look like? What does a software team look like? So if we start with the first question of what's a team, right? Let's try and answer this question first. So a team is definitely going to have developers, right? Both front-end developers, back-end developers. So they're going to do some UI coding. They're going to do some server-side coding. They are going to do some form of database designing, database scripting, right? So there will definitely be a lot of developers in the team. The next role is when the developer finish working, right? There will be some kind of quality assurance or some form of testing. Now, these two words are very different. Testing is very different than quality assurance, but then let's tuck them under one category and call it QA and testing. They are once again going to do functional testing, the UAT testing, right? But then the work entirely is going to be part of the QA work. Then there will be project managers, right? They'll take care of the contract, the requirement, the internal functioning of the team, and stuff like that. There will be uh, definitely a client, right? A client is somebody who's going to give you a requirement. A client knows what they want eventually or what they want that application to perform, right? Once all of this happens, then the code that we have developed using these dev team, what we have assured, right? What the client actually asks for, we are going to deploy it. And for deployment, we need administrators. Now, these administrators, they're going to have access to server computers. They are going to be experts of operating system. They are going to be experts of multiple tools like a web server, right? So these administrators, their responsibility will be to pick up everything that these developers have produced, the output of this exercise, and put it on a computer from where the end user of the application they can access uh, they can access the work that is done in this using in this entire cycle. So these are the people involved in the team. Make sense? But then if I talk about the software development process itself, right? What does software development involve? A software development is going to require some form of client requirement, right? The client is going to be is, the client has a problem statement, right? That problem statement could be because of a future opportunity that they see or a government mandate or some other motivation that is making the client, the customer, create something, build something, and they are using software to achieve that, right? So there will definitely be requirement, right? When these requirements they are identified, they are pretty sure that there's a software they want to get built. The next phase that kind of starts. Probably I can come here and mention a couple more categories. One such category is going to be an architect. So probably project managers, and there will be architects or tech leads who are going to have a better clarity about how this particular software development process is going to go through, what technology we're going to use, how these different pieces of software they are going to communicate with each other. So there'll be another role which is going to be architect or tech leads. Now they are going to do the designing work. Once the designing is done, then developers and QA they are going to uh, they're going to get in picture and the actual development work is going to start. Probably I can put testing as well. Now this testing is going to be verifying the requirement that the client specifically asked for is getting implemented the right way. The development itself could include the TDD and unit testing work that we discussed some time back. Right, if I can continue down this road, after testing, once again, there will be deployment. and then this deployment is going to be taken care of by these administrators, right? So this is the regular software development lifecycle. Once the software development process is complete, there is another word that I'm going to use, and probably it is, I can use multiple words for this. The word that I'm going to stick to is a combination of operations, or probably the services and support team. In the support phase, the application is already deployed on one of the server using some server-side technologies, some web servers, and the support team job is to make sure that the application is up and running. So keep the application running. For testing, they are going to look at, uh, they're going to monitor the application. So it's called monitoring. There will be some form of logging as well, right? What we have seen in the TDD classes is that using multiple design and coding principles, we can do software monitoring through logging, we can do exception handling, and then we can track what kind of failures our application is going through. Make sense? Now, now, just because you are done with development, it does not mean that you're going to pick up that application and you're going to throw it on one of these servers and let the client use it. As part of, okay, let me go ahead and use this section itself. As part of the operations, you are not going to do every work in production. So you're going to define different type of environment, right? You can have a dev environment where the developers are working. Once the developers are satisfied, or after a certain period, when the QA is is ready, or when the dev think that they have made enough progress, and then the QA should start testing it for the software development requirement given by the client, the work can be pushed to a QA environment, right? And when the QA is satisfied, the work is shown to somebody from the client end, and it's called user acceptance testing or a UAT environment. So user acceptance testing is the end user of the application, or the one who is funding the application. They are going to validate the work at their end, and once they are satisfied with the results, they are going to give an approval, and then that work is going to make it to the production environment, right? So instead of one web server, instead of one type of deployment, you're going to have 4 different phases of deployment. Each phase making it closer to the end user, and this is how the software development process is going to flow through. Now, there are a couple of challenges in this. When the requirement comes, right, the developer probably would already be working on a couple of things, right? When they are done working, the QA team would be waiting. Like, the development is not finished, the QA is going to wait. The project manager's objective is that developers finish the development work, the QA finish the testing work, and we make sure that we are meeting the deadlines that the customer is setting up. Generally, the flow is not going to be extremely smooth because sometimes the requirements aren't going to be clear. Sometimes the design that the architects are giving up, they're sharing with the developers and QAs, those designs, they are not received the right way. Development is going to have issues, testing is going to have issues, the deployment themselves, they are going to have issues. And then the way we are looking at the people involved, there is there are small silos. They are divided in small groups, and they're working together in their own specific areas. In between, because so because software, by the nature of it, the expectation is that it is going to be flexible, right? As the client, as the customer is looking at the application, they're going to get more requirements, more ideas, and they would want a flexibility of change inside that application, right? Some things they were not clear to them when they first started with application development. So the initial set of requirement that we are going to receive, they are not always going to be perfect, right? It is never going to happen in your software career that the requirements that are given to you, they are perfect and there were no change as you were building and developing the application. All the practices, all the coding styles that we saw, the solid principles, the design patterns, they all have like one common objective, that the software requirements are going to change, and then our code, it should be written in such a way that when the requirement change, we are able to accommodate that new requirement, and our code is able to adopt to that new ways of doing things. But then for that, uh, for that to work, a lot of effort and a lot of different type of activities that are required, that'll go into that are going to go into the practices or the methodologies of developing these softwares. Now, part of the problem is that when developers finish, what they are going to come up with is a set of, say, a DLLs, right? A bunch of HTML files, CSS files, JavaScript files, which is going to get packaged together, and then this package will be handed over to the QA team. While the developers are working, the QAs are going to sit idle. When the QA is working, probably the administrators, they'll be waiting for the QA to finish the handoff. And as you can see, there is a lot of waiting going on, and the customer, right, they are waiting for their new set of requirement. There is a term called value stream mapping. So in value stream mapping, there are multiple parameters that get captured. So if I can whiteboard this, the requirement that are received from a customer, they are they are called functional specifications, right? They only tell you the functionalities, that what is the expectation from this particular software, right? This functional specification, they you will have to devise a strategy of, based on these requirements, how what kind of code and what kind of files or instructions that we're going to generate for the computer. And over here, a general strategy is that we use some form of source control. A source control is a place where all the developers in the team, they are going to put their work. When there are multiple people involved, you cannot work in individual machine. I cannot create a folder on my machine, create all the required files. I will have to figure out a strategy of sharing the work that I created with the other team members. And to do that, source control is the go-to thing. Now, over a period of last 30, 40, 50 years of IT, the source control technology, it has kind of evolved, and developers have been using these solutions to share the work across different team members. Now, this source control is the first place where a new requirement is going to find its spot. So when a customer comes and says that I want a specific feature added to the application, they are going to go ahead and create special branches or special folders that are going to point to that particular functional requirement. When this thing is sorted out, the developer is going to go ahead and start the coding work. Right? So what we are doing is this little block here, we are converting it to um, a representation in the form of picture, and we're going to talk about how this thing is related to value stream mapping. All right. So once this is identified, you are going to, the developers, when they finish their activity, the QA team is going to pick up the work, and then this work is going to be the test cases that they are going to write. So remember that text file where different functionalities and different activities that need to be performed for verifying that, for example, say login button is working. When we are creating an order is getting reflected in the database. And when we are reading back from the database using, say, entity framework, that data is appearing back on screen. So part of the work is generating these test cases, and the next phase of testing is going to be actually testing the application, right? So this is where the actual work is going to happen. And when this thing completes, then we are going to create a package out of it, right? A package is, say, an archive, a zip file, or some form of deployment strategy, which is going to take the entire work happened in this phase, which was validated here, and it's going to become a package. This is a package that the administrators are going to take and they're going to put it on special places on the server, and through that it is going to become available on the server. Right? The next phase is going to be the UAT phase, where the client is going to observe it in one of our environments, and when they're convinced that this activity is working fine, right, they are going to go ahead and do a production deployment. Let's go ahead and assign some timelines to this. When when new requirements arrive, probably it is going to take 3 days to understand what those requirements are. This is where the project manager, the architects, the tech leads, they're going to involve very, very heavily, and they're going to do some, say, brainstorming, a lot of discussions, a lot of meetings where the requirement, the expectation, the ask of the customer, that'll be grasped and understood. Once this is understood, the designing work is complete, the coding efforts can begin. Probably based on how good the requirements are communicated, it is going to take, say, 4 or 5 days. Once this completes, uh, the testing of that application is going to take like 2 days. At least coming up with a script or what functionality need to be tested, how it should be tested, that scripting work, it'll be completed in 2 days. The testing itself is going to take, say, like 3 days. Once this is identified, creating the package, identifying what DLL is supposed to go in what folder, where do we deploy the UI, right? Figuring out things like that is going to take another couple of days, right? Once that happens, then the UAT deployment, creating a new environment, and then making sure that all the files are copied in higher environments as well at the right places is going to take additional 2 3 days, right? Then comes the part where you're going to involve the management and the client, and by the very nature of business, the business people, they are generally very difficult to get hold of, and there will be some lag where when you inform the business and they come and they validate the requirement that are supposed to be implemented, right? But then once they see it, the production deployment, because of all these phases here, it can happen a little quickly, and it can be moved to production, say, over a weekend or late at night. And the application, the requirement that we received here, is delivered to the customers over here. So the customer, what they actually ask for, they will start seeing it in this phase here, right? So they are all, these all phases, they are all connected, right? There are two terms that we should discuss at this point. One is um, a lead time, and second is a process time. So lead time is the total the total amount of time, the total number of days taken when the requirement arrived and when the customer foresaw that requirement. So let's go ahead and start adding it. 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 21, and 22. The lead time in our example is 22 days. Process time is the actual amount of time that is required where actual work happened. So the actual work happened in the coding phase and in the deployment phase, right? Everything else is part of process, right? So the process time of this particular flow is actually 5 days. Now, based on this, you can calculate the efficiency of the team. So the efficiency is 5 days of work and 20 days of time. The team efficiency is a little over 20, like about 23, 24%. All right, so this team is not very productive. Like 75% of the time, the people are sitting idle or they are involved in some activities that are not contributing to realization of value. Value is when the requirement arrived and when it was handed over to the customer. Right? So the functional spec, the requirement that we received is the value that the customer is expecting. And we are working on the application, but then while we are working, we are also investing, spending a lot of time in figuring out how that work should be done. Right? And then the smaller this number, the less efficient your team is. An ideal value for this, which is utopia, it is probably never going to happen, is 1 or 100%. That when the customer is asking for value, they are receiving that value like right on that day or immediately, right? Or the entire uh, work that we do in software development, it happens, it is contributing to generating that value for the customer. With that, I'm going to let's switch gears and talk about why there is a waste of why there's a waste of say 75%. Right. So this is where I'm going to attempt to define DevOps. So DevOps is the dev team and the operations team. They are working together so that the customer they realize the value of the software or the value that the customer is expecting. Right. So if you go to a software company and then you hear out the problem of everybody who is involved in this in these roles, you will end up talking to all of these people. Now, the developers, they're going to say that they don't receive the designs the right way. The message, the communication, that was not clear. The QA is going to say that developers, they don't generally create the code in such a way that that it is testable. Uh, they sometimes have to wait for too long before the code is available in, say, a QA environment. The administrators team, the operations team, they are generally going to say that the package that is received, a general complaint of them is going to be that when they deployed it, the production functionality is not kind of working. And when this thing is discussed with developers, they say that it is working on their development machine, right? All of these problems they occur because the developers, the QA, the architects, the operations team, they're working in their own independent silos, right? So DevOps is actually a combination of two words. One is developer and the second is operations, right? The combination of developers and operation together is called DevOps. The idea here is that developers and operations team they should work together and all these phases of application development it should not happen as one step after the other, but then the deployment team and the requirement team, design, development, testing team, they should all be brought together in one room and they should work together towards that common objective. So as the requirements are getting finalized, the deployment team, they will also be involved in the designing phase, in the development phase, and they'll be constantly informed about how the what the delivery plan of or the deployment plan of this particular incoming requirement is going to look like. Right? And then if right, there's a term called cowboy programming. So in cowboy programming, the requirements are not given to developers the right way as to what they are supposed to build, what they're supposed to implement. And to solve that problem, DevOps it offers at least three things. So DevOps is combination of three things. One is people, second is processes, and third on excuse me, third is the tools, right? So when people are working together in a specific process oriented format and they are using the tools that are available, um, the we can start delivering value to customer on on an ongoing basis, on a regular basis, right? So the objective of DevOps is to bridge the gap between people through processes and through tools, using which they'll be able to do software deliveries the right way. Okay. Now we have already seen that there are multiple phases involved in software development. There's requirement, there's design, development, testing, and deployment. And this is going to bring us to our next set of um, next set of discussion. So people, we have already seen that there are developers all the way up to operations team that are involved in processes. Okay, we're going to talk about processes very shortly. Let's focus on tools. We are going to use Azure DevOps for the rest of the discussion. And then Azure DevOps, it offers at least five type of tools that we can use for realizing for for doing DevOps, right? DevOps is combination of people, process, and tools, and it is used for delivering value to the customer on an ongoing basis. So the first thing is called Azure Boards. The second is Azure Pipelines. Third is Azure Test Plan. The next is Azure Repositories. And the last is Azure Artifacts. Right now, an Azure board is the place where we're going to track our requirements. Right. Once those requirements are identified, the development work itself. Remember talking about this section here, the source control. The source control of the application is going to happen inside the Azure repos section. The repos earlier were more with TFS, Team Foundation Server, but then now uh, people are leaning more and more towards the gateway of um, managing code and having version controlling. Okay. Once the code is created, we are going to have a test plan running parallelly, and this is where our coding examples of TDD and test-driven development, they are going to come in picture along with a lot of other and different type of testing. Once all this happens, then Azure artifacts, they are going to get generated as well. So if I have to tell you what artifact in summary is, it is those NuGet packages that we added to our solution. Right? They are going to become part of the Azure tool, that the Azure DevOps tool that we are going to receive. So the development is done, the requirements have been received, the development has been done. Uh, the dependencies for the development and the outcome of the development is also available. It has also been tested using, okay, let me go ahead and put another word here. I'm going to call it TDD, is at least one term. There is another type of testing, it is called BDD, and there are some other testing that we're going to talk about. So once this is identified, for deployment, we are going to use the Azure pipeline. An Azure pipeline is automation of when a package is available after the testing is completed, right? That package, it can be deployed to one of these four environments. And then pipeline is automatic way of pushing your code from one environment to another based on some programmatic rules, right? Uh, Part of Azure Pipeline is going to be our discussion in the future sessions where we're going to talk about Docker and Kubernetes, right? So the requirements, they are going to be available over here, and Azure Pipelines, that is going to happen, it is going to handle the deployment of our application, right? So we have defined the first part, the people that are involved in a software project. We have defined the tools that we're going to use for the software work that we have. Now, let's come to the third part, and that is the processes. There is another Azure or DevOps diagram that I have seen. I'm looking for that diagram. Give me one moment. So, the problem with cowboy coding is that the requirements, they're not flowing in the right way, and because they keep coming out of order, the delivery is kind of going to get affected, and the time that we are wasting here because of the operation delay, because of the process time, it is going to keep adding. The testing is going to get difficult because the code base size is increasing. Making changes to the code is going to get difficult because the code has not been written with the right programming strategies. Okay, and then it is all happening because we don't have a structure of dividing the work that we are going to work on. And to figure those things out, what DevOps proposes is that we do work in at least four phases. The first phase is going to be the planning phase. The second phase is going to be the develop phase. Then we're going to deliver and we're going to operate, right? Now, these four elements, it is not going to happen in a small, and it's for the entire application. The planning is going to help us pick up a very small piece of the application, and we're going to plan only for a small consumable chunk or something that our minds can comprehend. Once that happens, we're going to start development. We're going to have practices like TDD where we're going to write automated test cases. Once that happens, we're going to deliver that small chunk of functionality so that the customer realizes value. And when that happens, we are also going to do form of logging and monitoring, which is going to help us give a continuous feedback about what that phase is going to look like. Let me go ahead and pick up a picture of DevOps. All right, this is better. Right. Okay, so the first phase of any project is going to be planning. In this phase, at least two things are going to happen. First is gathering a requirement and designing the application. Once this work is completed, we are going to move to the second phase, which is the coding phase, which is the development phase. In this phase, the actual code will be written for the application, right? When this happens, we're going to build the application. This build is going to relate to this Azure pipeline tool. When that happens, we're going to move to the testing phase. Inside testing, we are we're going to validate the functionality, the acceptance testing, all of that work. When that happens, we're going to do the release. The release is moving code from, say, a developer machine from the repositories to a higher environment. When that happens, when everything goes through fine, we're going to deploy it to a production environment. It is going to go in the operation mode. This is where all the activities of the application are going to get performed, and then we're going to enter the monitoring mode. In the monitoring phase, we are going to validate that the application is performing the way it was supposed to perform. We're going to keep a tab on the logs and um, the application performance parameters, and based on this, probably the next phase or the new set of is going to start, or we're going to start with a new set of requirement. And then, as you can see, that this looks like the infinity sign. It is a never-ending, never-stopping process. As part of DevOps, um, the work is going to be an ongoing thing, and it is going to be a combination of development and operations. Part of the planning is um, going to be selecting the way you would pass on the requirement to your team. And this is where I'm going to go back to our original list, and we're going to talk about what software development is going to require, right? So you've already seen that everything happens at the requirement phase, right? My To fit everything from the requirement side, the functional spec that we receive, right? How we are going to fit in the Azure board and how those requirements should flow in is what we're going to discuss next. If I scroll down, all right. So I've called it product development, but then what I want to say, what I want to communicate is the product management is going to be the phase where the business is doing the research for the application that they need to build, and it has its own process. So before you want to build an application, you will have to identify something called as personas. And probably I should take a moment and talk about forward referencing. When we are discussing theoretical subjects, one very important word is forward definition, right? We are going to use terms for which we don't have a definition, and probably the rest of the discussion for today is going to be a lot of definition that that we'll be discussing. When you are building a product or a software, right? The software is going to have a lot of end users. So suppose we are building a CRM application, right? Let's go ahead and do a quick sideline discussion. See, a CRM is customer relationship management or management of relationship with your customer. But then who is your customer? Right? A customer is somebody who is buying your product. Probably that is a little late in the timeline, right? When the customer is buying a product, that is he has already become your customer. But then before that, your customer is going to see an advertisement on the highway hoarding, right? So the person who is looking at these advertisements, they are your potential future customers. And advertisement and marketing is an important phase of a CRM application, right? Once that happens, the customer is going to probably give you a call on your toll-free number, 1-800 something, right? When you receive a call, this customer, right? I'm going to write customer here. The customer is going to become a lead, right? Now, the same customer, potential future customer, over here becomes a lead because he has placed an inquiry in your system. Once you have that inquiry, the customer has shown some interest in your product, right? You are going to send them a quotation, right? This quotation is going to become their initial idea of how much money they'll be spending if they want to buy your product or service. Right? Based on this code, somebody from your team, somebody from the product team, they are going to be constantly in touch. They're probably going to negotiate rate. And when the customer agrees, they're going to send a purchase order, right? A purchase order is the customer's intent of buying your product, or probably a confirmation that they're definitely going to buy your product. Once that happens, once you receive the purchase order, you are going to probably ship the product, you're going to send them the product, and you are going to take the money from them. When the money arrives, you are going to send them an invoice, right, for the purchase order that they have sent, that based on, say, the amount of rupees 5 lakhs that you're placed for, right? This is the invoice, and the invoice is going to have breakup of the actual amount and probably the taxes as well, right? Now, the customer at one point is going to stop using your product, right? And they're going to have some feedback about your application, about your product or service, that they like the product, they did not like the product, they're done with the product. But then, even if the customer ceases to use your services, your products, they are still potential customer, and you would still want to stay in touch with them. Suppose you create a new version of this product, you're going to send them notification that, hey, there's a new version that has arrived. Are you interested in that particular new version, new product upgrade, right? If they are interested, they're going to place an inquiry again, and this cycle is going to continue. So this is the general flow of a CRM application. You are managing the relationship with your customers even before they bought your services through advertisement and marketing. After they buy your services, you give them an experience, and after they stop using your services, you still try to market additional product to them. Uh, the different words that we have seen here, one is customer, the second is lead, then there is another term that we have seen, it's an inquiry, probably there's a quote, there's a purchase order, there's an invoice, there are taxes, right? There is additional marketing effort or feedbacks or reviews that you would want to gather. One system is going to have multiple people involved, right? The person who is generating the quote is going to be probably from the sales team. The person who is going to generate the invoice is probably going to be from the accounting team, probably an accountant. So the words that we have already seen, these words or the people that have interacted in this entire flow, they become what we call persona, right? As a part of product development, as a part of software development, one of the essential things, the first things that you're going to define is you define or you talk about a persona. What happened here, what happens in a world where we do cowboy programming is that requirements are given to the developers in a very ad hoc way, in a very unorganized way. And when information that flows in is unorganized, the development efficiency of the team is going to go down. They're going to spend a lot of time in processes. To do product development the right way, the product team, the client, or some special roles from your team, they are going to help the customer identify these personas. Once these personas are defined, they are going to define, they're going to map to different story. And the next word is story mapping, right? Story mapping is how the customer is going to run through this entire flow and what will be different interactions that they're going to do with the system. So they're going to do story mapping that this person is going to do certain activities, certain interactions with the system. Once that is identified, some stories from a developer perspective, they are going to be extremely big, they're going to be extremely long, and they'll not be able to uh, fit it in in a consumable time, in a time that can be estimated. In that case, you're going to you're going to split the story. Like the customer who is just looking at the advertisements, right? You're going to create one story out of this, and probably the next story is going to be what happens when they place an inquiry. Next story, what happens when they request a quote, right? So you're going to identify if the work that you are discussing, it can be adjusted or it can be delivered in a considerable amount of time. And okay, once that happens, once you have split your stories in a bigger way, you actually define a user story. Now, a user story is an English-like sentence which is going to generally have this model as a, and then you have some empty space. I want to, and then you have some empty space, and then so that, right, and then some blanks. One story for a customer, we're going to write as a customer, I want to, or I'm going to say as a business, I want to display advertisements to the customers so that people become aware of the product that I'm selling. Right, so this is just one story. In an application of the capacity of CRM, there are going to be thousands of stories and they are all going to follow this structure that as a something, I want something so that something happens. And then this so that statement here is extremely important because without a reason, the developers, the design team, everybody is going to be very lost. It is a so that statement, the testing team or um, the quality assurance or the test driven development is going to get verified. Okay, once that happens, there is another term called 3Cs, 3Cs, and then these C's here, they stand for a card, then conversation, and then confirmation, right? A card is this little note here that as a customer, I want something so that I'm able to get something done. It'll be written on a specific card. But then around this card, there will be multiple round of discussion that is going to happen with the client, right? There'll be multiple email communication, phone calls, there'll be discussion with the technical architects, the tech team, and all that conversation needs to be recorded, right? And then when that conversation is reaches a finishing line, we're going to do a kind of a round of confirmation with the client that this is our understanding of the application. Does this sound correct? Right? And then once we have that confirmation, we have kind of defined the 3Cs part of a product development. The next thing is invest. And invest is an acronym. Each letter stands for each letter stands for um, the way a story should be written. So I stands for independent. Each story should be independent. When you're writing a story for a customer, it is only going to be about customer. When you're writing a story about an accountant who is going to generate the invoice, it is only going to be about the accountant. So I is for independent. N is for negotiable. We are open to discussion. If something does not sound right, something does not feel right, we are willing to go back and change this statement here. The next letter is V. V is for valuable. There is some value that the customer is going to realize when this particular story is completed. E is for estimable, and it means that with some guarantee you can commit that yeah, I can finish this work in say 1 week, right? Or probably this is what it's going to take. So you can estimate the resources that it's going to require, the timeline it's going to require. S is S is for small. The work that you're going to do here is not going to say that as an accountant I want the ability to manage account, right? Because that is going to be a lot of work. As a bank, I want to do banking so that people can bank with me. Right now, banking is a massive application, and that is a terrible story. Right? You want to do something very small that as an account holder, I want to withdraw money. Right? So something that can be consumed by the difficulty can be consumed by mind. It should be small enough. And T is for testable. Right? At some point, you should be able to define the test cases, the TDD for this particular activity, and you should be able to write some automation test cases for this. Once all this happens, right, you are going to get in the mode of incremental development. In the incremental development mode, you are going to repeat this entire cycle of product management like multiple times. Right? So you are going to identify different personas. You're going to identify what actions they're going to do in the system. You're going to break those actions. You're going to write user stories against those actions. You're going to keep the card, the communication, the confirmation together, and then your stories, they're going to follow a pattern of invest, independent, negotiable, valuable, estimable, small, and testable. All right. So all these 6 attributes, they are essential for the stories that you are writing. Right? And this is how probably your entire project management, product development phase is going to look like. Once that is identified, then we are going to follow a strategy called, for this discussion, we're going to call it Scrum. Okay, there are other software delivery methodologies in which you can you can ensure that the delivery happens. Once again, going back to this old diagram where the work was happening in bits and pieces, like requirements were flowing in from out of nowhere, and the dev team, they were disturbed and there was not a lot of efficiency. So we are going to go to this second phase of DevOps. We have figured out people, we have figured out these 5 tools, and now we are going to talk about processes. The first process that we discussed is about product development, product management. The second phase itself is going to be about how an effective team is going to do the work. And the first term that we are going to discuss here is called backlog grooming, right? Now, to understand what backlog grooming is, we'll have to understand what backlog is. What a backlog is. Now, from excuse me. Now, from the product management phase, we've seen that we are building user stories. User story is going to become part of backlog. Right? There are other kind of activities that you can figure out uh, excuse me, inside the backlog, but then user story is definitely going to be one. So it can be defects, it can be a new feature, it can be infrastructure changes. So if your dev team decides, or if your operation team decide that it is not going to require, say, 4 environments, or probably two environments, like from dev we are directly moving to production. The uh, operations team, the deployment team, is going to say that I'm going to require, say, 2 more environments because the last time we tried deploying, something failed. So infrastructure changes, they are going to become part of this deployment as well. I'm so sorry, they're going to become part of this backlog discussion as well. Once the backlog is identified, we are going to get in a phase where we can estimate or we can comment something about the timeline it is going to take for building that application. And the the process or the Scrum element that is going to help you identify that is called planning poker. Now, poker is that card game which is about not having an expression on your face, and you're gonna comment on the development process. Now, I'm pretty sure that you all know what Fibonacci series is, right? So, Fibonacci series is the series of numbers that that we're going to use in the planning poker phase. If a story will be given difficulty level, and based on the difficulty level we are going to commit on how much effort it is going to take for delivering that particular story. So suppose if somebody knows how to make a cycle, right, and cycle is the easiest thing that you can develop, right? So because it is the easiest thing, you're going to say that this is one. But then if you compare a cycle to an airplane, right, how difficult it is to build an airplane compared to a cycle. Probably it is extremely difficult, right? You're going to give it a user story of T. Right? Now, if somebody says that one story should take 1 week or one iteration or 1 day, 1 hour, right? They are estimating the wrong way. Agile or uh, Scrum, it is not about time. It is not about hour. It cannot be counted, right? It is the difficulty that uh, that you assign to a specific activity, and the difficulty of one indicates that the work at hand is extremely straightforward. Okay, and 13 here does not mean that it is 13 times more difficult compared to a cycle. It indicates that you don't have the ability of commenting about the difficulty of this thing, and this is where this little phase is going to enter again, which is story splitting. When you see a story with 13 points, like, you are not going to work on that story. You're going to split that story into smaller consumable chunks that, yeah, for building plane, probably I'll have to build a mechanism for landing, for takeoffs, right? And they are going to be a massive story in themselves. So suppose if you build a story for takeoff, that is going to be another 13, right? Landing is going to be another 13 because you don't know all the activities, all the tasks that are going to go in for the takeoff to work the right way. All right, so 13 does not mean 13 times more difficult. 13 means uh, that it is something that your mind cannot pursue. All right, so that game itself is going to be called planning poker. The entire team, the project manager, the client, the developer, the QA, the deployment team, they're all going to be in one room, and they are going to give estimates about how long it is going to take for that particular user story to finish. Okay. With that, we're going to move to the next title, and it's called relative estimation. Now, relative estimation is what we have already discussed here, that you are never going to comment of how much you are going to, how much effort it is going to take. And once again, I'm going to give you an example of this, right? If you look at this series of letters, they are t-shirt sizes, right? Anybody who is not fitting in the small t-shirt, the shopkeeper or the salesman, they're going to recommend them that, sir, you look like an M, right? You want to try an M. But then there is no defined guidelines as to how big an M is compared to an S, right? These sizes are available for kids as well. These sizes are available for adults as well. A relative estimation is compared to what you have at hand, how big or how small it is, right? And at one point you give up and you fall back to splitting this thing into smaller consumable chunks until you have a relatively small size that your mind can pursue and you can work on it. The next word in Scrum is going to be point estimate. Point estimate is another word for man hours, right? But then as long as possible, you are going to avoid this. A better term for this is going to be, I'm going to use another word here, and probably it is not related to Scrum, but we're going to discuss that here. The word is called velocity, right? Velocity is um, the number of story points that get finished in a given iteration. We're going to talk about iteration as well very shortly. And what I'm doing right now is called as forward referencing. So I'm talking about words that I have not defined yet. Uh, so velocity is in an iteration how many stories one person is finishing or one team member is going to finish. If I pick up a story and I say that, hey, I can work on two story, one for accountant, one for say the customer. The customer can log in, the accountant can print invoice, and those stories are 2 and 3 points. At the end of the iteration, my velocity, individual velocity, is 3, and suppose the entire team is working together on this application, they are finishing like 5 1 stories, 5 2 stories, then it is going to be my velocity of 5, then 5 plus 10 15, it's going to be about 20, right? This is going to help us plan the next phase of our application. But then this is point estimate, that you are going to calculate man days and man hours in terms of velocity and the number of stories that are getting finished. The next term in the world of Scrum is definition of ready. Right? Inside definition of ready, you say that the user story that is assigned to me, say login for customer, I'm going to start working on this uh, user story when I have everything that I require to work on that, right? And that could be, say, input from the end customer. There is going to be another exercise. We have a class for that in the future. It is called user experience, right? The application designing, it does not happen in silo. So there's a special role in the team. They are taken by something called as design thinkers. A design thinker is going to sit with the customer or with the product manager, and they're going to observe the people who are going to use the software in their scenario, right? He's going to work very closely with them where they work. Probably they're going to go and sit inside a bank. They're going to go sit inside a service provider company or product development company, and they're going to observe the work that they do, right? And based on those work, they are going to devise a special um, a design document, and that design document is going to say that, hey, if you give user ID and password and hit a green button, they'll get signed in. If they hit the red button, they are going to get kicked out from the system. So a design thinker generally comes up with these designing. Definition of ready could be that I have received the design from the UX person. UX is user experience. Anybody who is doing this UX designing, it is one of the essential required pieces for me to pick up on and work on the story. So somebody is going to provide all the required essential starting point for the definition of ready. Now it is already 9:07 on the clock. Let's take a quick break. We're going to come back in exactly 10 minutes and we're going to resume the rest of the discussion. Thank you. And we saw what backlog grooming is. For backlog grooming, we need backlogs. Backlog, one of the element of backlog is a user story. There could be other elements like infrastructure related discussions or probably defects or bugs in your application. They all become part of backlog. Using planning poker, we're going to assign some weightage to the elements in backlog. There is a relative estimation that we're going to do. We are always going to compare one thing with something that we have already done or we have already worked on. Then there is point estimate and definition of ready. Definition of ready, it means everything that we require for delivering something is available to us before we actually pick it up and we start working on it. Then on the similar lines, we have definition of done. Definition of done is the counterpart of this. So for definition of ready, you will take everything that you require for working on it. With definition of done, you are going to finish your work. That a definition of done is, say, a C# file, like DLL file, HTML, CSS, JavaScript files, probably also the unit testing of the application, right? So it is up to the team or the Scrum Master to define, or the entire team together to define what a done looks like. Once that is completed, then we're going to talk about task board. A task board is a place where these user stories they are placed, and I think at this point I can show you a diagram. I show a task board. Okay, let's just search for task board. A task board is going to look like this, right? So it's a physical place where little sticky notes they are pasted on a wall or on a board, and it has multiple columns: to do, doing, and done. Anything that is on the left, this becomes part of the backlog, which is not yet started. For to do is something that we have picked up because the definition of ready was completed. Doing is you have actually started working, and when you're done, when the definition of done is met, you move it to the last column. So this is a simple task board. Right, in real scenarios, all right, so this looks like more actual picture, right? People use their board in meeting rooms like this. Okay, so this is a task board. It can be physical, it can be online, doesn't matter. And with that, I'm going to close out of this. And okay, so the next word is burn down chart. Now, as you're making progress on these user stories, you are finishing them. Everything that we have picked up, like 5 of 1 and 2 of 5 and 3 and 5, if our team has picked up different stories, right? These user stories here, or probably items from the backlog, and then they have different weightages, the estimates that we have assigned during the planning poker phase. As you are making progress in your iteration, the stories are going to get completed, and when they are completed, the burn down chart is going to indicate that what your progress for the current iteration is going to look like. So you had picked up like 5 stories of 2 points each, so you were at 10 point, and then as you were working in the iteration, it is going to go to 0 point, right? So this is a burn down chart which indicates that work is getting completed. The next Scrum definition is 3 questions. So every day, each team member is going to answer 3 questions. What they did yesterday, what are they planning to do today, and if they have any blockers. Right? Answering these 3 questions is enough to inform the entire team the work that is in progress and how things are moving forward. Right? And so the reference point for this is the last meeting. So in the last meeting, you say that I'm working on story number 1. Right? Then I am facing some blocker that the C# code is not working, for example. You're going to talk only about these three questions, and this meeting is going to be extremely short. So with that defined, there will be daily meetings where everybody is going to answer these three questions. So daily meeting is an important part of the Scrum methodology. All right, then comes a word that we have used multiple times already. It's called an iteration. For this, I'm going to look for another diagram, and I'm going to search for Scrum, and then let's see if I can find a good image. All right, I think I can live with this. All right, so in a sprint, we are going to have multiple iterations. We are going to start with planning, we're going to do implementation, review, and we're going to do some retrospect, some forward definition. But then daily Scrum is going to be that one day meeting where we are answering those three questions, right? There are user stories that are going to go inside a sprint. A sprint is 2 weeks of window. So it can be from 1 week to 2 months, but then a lot of teams they have settled for the window of 2 week. 2 week is long enough for people to get some work done, and it does not become a lot about meeting, and it is not big enough that people lose the context. So sprint it always keeps them on their toes, that they are picking up user stories and they're working on those stories, and they have some progress to report every day. So this is a general iteration. Then the next term is called time boxing. So in time boxing, you have already committed that a particular work is going to take this much time, or for this much time, I'm going to try something out. If it works, it is fine. If it doesn't, that is fine as well. And in the Scrum, you are going to repeat all of these activities, right? My question is, where in the Scrum we are doing coding? And we have not defined that yet, right? There's a task board, there's a burn chart. None of these titles that we have discussed so far, they are talking about doing the actual work. In fact, when we discussed product management, I also wanted to talk about designing. Right now, software designing is an extremely difficult thing, and it has its own terminologies. And the first and the most important word is ubiquitous language. Right now, ubiquitous, if you look up the dictionary meaning of this, it is going to mean that it is present in all the places at the same time. It is an attribute of God. A ubiquitous language, in terms of the agile methodology or DevOps world, it actually means that the product development that we are doing is uses the same terms that we are going to use inside our application, right? So as part of software designing, ubiquitous language is extremely important. The business and the dev team, they should be speaking the same language. Now, we've been looking at the entity framework core application, and we talked about students and university and instructor multiple times. Now, if developer is coming from a different culture, a different background, they are going to have different terminologies for that. Like for instructor, you might call teacher, right? For uh, for a student, you might use some other terminology. For course, you might say class, right? For enrollment, you can say sign up, right? And then these terminologies, they should always be defined by the product. Like in 90% of the cases, because they are the end users, they are the consumers of that application. They know the domain. And the word itself, ubiquitous language, it is coming from a subject called DDD, which stands for domain driven design. So it's a software development technique that puts the domain in the center of everything. When you are building an application, you are in a domain, right? And that domain has specific language. Like when you see words like account and product and order and purchase order and invoice, you would know that this is a CRM domain. When you see human resource, person ID, person email, sick leave, timesheet, you would know that you are in the human resources domain. right? So each domain is going to bring its own set of terminologies. And as developers, as architects of the application, it is your responsibility to pick up the same language. And when you're defining classes, when you're defining HTML files, CSS files, you are going to carry that language inside your code as well, right? So that eventually the the gap that we were discussing here, that work is flowing in an ad hoc way and we are not able to relate to what the customer wants, and we are wasting a lot of time in process rather than doing the actual I'm so sorry, we are wasting a lot of time in the lead work rather than the process work, which is going to deliver value. If you want to bridge that gap, your usage of ubiquitous language is extremely important, right? You should be speaking the same language that the client is speaking. Make sense? The next terminology inside designing is simple design. The software that you are implementing, you don't have to think about all the features and all the functionalities at the same time, right? That we're going to require login and reporting and exception handling and monitoring, all of that. You start with a very simple piece, a functionality that can be consumed or delivered in as an embarrassing release, right? But then it works, right? Something that can be demoed to the client, and the client would be like, you know what, this looks fine, but then I want the UI changed. So your design should be extremely simple, something that can be demoed, right? The next phase, the next word is refactoring, and I think I have already shown you a couple of examples of this. When you write piece of code, your first release is never going to be perfect, right? You are going to make a lot of design mistakes. Your code is not going to be according to the best practices of writing code, and that is completely all right. Okay, it is always the next iteration that your code is going to start to improve if you understand the refactoring techniques. So refactoring is a very important aspect of designing, and don't ever try to get in the mode where you are building the entire application right the first time. All right, because that is not going to happen. Then you're going to try to so there is another term called rule of simplicity, and rule of simplicity, it okay, let me gather my thoughts. All right, this relates to this phase here, right? Or if I scroll up and talk about the tools, it relates to this phase here. It is only possible to test simple application. So the rule of simplicity says that the code that you are writing, it has to be so simple. The component that you're producing, it has to be so simple that we should be able to write automated test cases for that particular functionality, right? And there are a couple of other terms like a CRC design card. It is So if I put CRC here, it's a design card, and C stands for class, R stands for responsibility, and C stands for collaborator. When you are As you develop application, you are going to require a lot of collaboration from other team members, right? They'll have specific responsibilities that for this particular activity, I require, say, a QA person or somebody from, say, a database team who can perform that activity for me. So CRC card is extremely important when you are doing the application design, because it is through this that we are going to assign the members or the team that is required for a particular user story. Make sense? So we have covered three pieces so far. We have talked about product management. In product management, we are going to define personas, we're going to define stories, we are going to identify user stories, and we are going to create these stories based on the rule of invest. Right? Once this is created, we're going to do software designing, and inside software designing, we're going to use the same language that the client uses, and we're going to apply these principles. Right? We are not trying to get our software right. We're going to refactor and improve the quality of our code. Then when it, the second thing is Scrum, where we are going to divide the backlog. So we're going to write thousands of stories, but then we don't have to deliver all of them together. We're going to reach out to a person who is a product owner, and the product owner is going to say that out of these 1000 stories or out of these 1000 backlog items, we are going to pick up, say, 10 for the next week. When we pick up those 10 items, we're going to run it through a planning poker, and we're going to say that it is going to contribute to so many story points. And as we are making progress, we're going to have a burn down chart, and we hope that at the end of the second week, the entire work that we picked up, it has been completed, right? So the next important piece in the agile world is, all right. So there are two more topics that I want to talk about. One is extreme programming, and the second is testing. All right. So if you look at all these three sections that we have covered so far, none of them talks about writing code itself, right? Uh, so because coding is not part of, say, product management or designing or the Scrum itself. Scrum is a way how we are going to work together as a team. If I go back up to this diagram one more time, right? Scrum is defining the wastage or uh, the difference between the lead time and the process time. And through Scrum, we're going to try and drop the waste that is happening in the lead activities, right? So Scrum is going to give us a better control or a better grip on the complaints of the team member that developer is not finishing in time, I'm not receiving the definition of ready, so I cannot start working. Those gaps, they're going to get finished inside Scrum, but then the actual coding is going to happen in extreme programming under the category of extreme programming. So extreme programming itself is about how the coding work should be done. The extreme programming says that a team is efficient if they can write the same amount of code for an extended period of time. So if you study like multiple organizations, you would find out that it is that a developer, for example, say writes 100 lines of code every day. Right now, if you divide organizations based on the sizes of those organizations, you'll find out that when it's a one people organization, he can deliver say 100 lines of code every day. When the team size grows, the number probably kind of goes up a little, but then it is not going to be 10 times, right? It is probably going to be 200 times, 200 lines of code. When the team size increases to 100, right? The development efficiency, it kind of starts reducing, right? And then if you say take a ratio of this, that lines of code 200, number of developers 10, then each developer every day is writing 20 lines of code. And then if you look at from business perspective, the business is going to say that I was better off as a one person company because one person was delivering 100 lines of code. But then these 10 developers that I have, they are not delivering as much value. Extreme programming says that regardless of the number of people in your team, you should always be able to deliver the same lines of code. Right? And the term that extreme programming uses for that is sustainable pace. Right? There is no defined number for this, at least not that I am aware of. But then sustainable pace, right? It indicates that the way a developer is contributing to the project, it should be sustainable. Right? If we relate it back to the planning poker, we have picked up a user story, we have assigned it 3 points. I took that story, I delivered that story in 2 weeks in the entire sprint in this iteration, right? So my velocity, my individual velocity is 3. Now in the next iteration, if I pick up, say, the biggest story, point 8, you should not have these big stories, but then for our discussion, let's say that I picked up this story with 8 points to it, and I finished that story. In the next iteration, I picked up a story that was 1, and in the entire 2 weeks of window, I finished only 1 story point. So my velocity in the first week was 3, the second week was 8, the third week was 1. This is not good. Once you identify the capacity of a developer, of a team member, it should be sustainable, right? Throughout each iteration, you should be able to deliver 3 story points, right? This is sustainable pace. So If that is not happening, then probably your planning poker is not working, or probably your user stories are not good, or probably you are falling back in this mode where the team were not very effective, and there's going to be a lot of lead time and process time. Okay, so that is sustainable pace, the first piece of extreme programming. The second term is pair programming, and this is very counterintuitive. Pair programming says that the developer they should work together on one user story. Right? It should not happen that one developer is sitting in his own silo using Visual Studio, writing code on his own and submitting the work in the end after 2 weeks to somebody else. Right? Pair programming says that on one user story, at least two developers should be working together. Right? And they would be looking at one screen. There'll be one pair of keyboard and mouse, and they are going to take turns of programming. So I'm going to write program for like 30 minutes, then I'm going to slip it to the next person. I'm going to give it to Ajit. Ajit is going to write for 30 minutes, and then we are going to switch role one more time. I'm not only going to do .NET programming, I'm going to sit with a developer as well. I'm going to sit with a UI person as well. And there's going to be a lot of overlap in the work that everybody does. One of the problems that we discussed when we were talking about DevOps in the beginning, or the issues in the team, is that everybody is kind of divided into their main skill set. If you build a team with skill set as the primary way of division, everybody is going to undermine the effort or the work that the other person is doing. The only way to break this culture or this silo is that you bring them all together and then you make them work with each other. So a .NET developer probably is working with a deployment expert, because for deployment you will have to do some form of automation, and for that kind of automation you will have to do a lot of Python programming. Right? So it is not that deployment teams, they are not effective, they are not as smart as developers. It is not true. They have different set of challenges, and when developers start working with deployment team, the kind of team dynamic it starts improving, right? Extreme programming, it also recommends daily meeting. So it is the first time that we are talking about an overlap. We have seen daily meeting as part of Scrum, all right? And this is where programming and the Scrum, they kind of intersect with each other, right? Extreme programming also talk about iteration. Now, what goes inside an iteration? A bunch of stories that you commit that we're going to work on these stories for the next 2 weeks. Now, velocity is the term that I discussed when I wanted to define point estimate or relative estimate. Velocity is the next thing in extreme programming. Velocity is the number of stories a team can finish inside one sprint. So a team of five, everybody taking point 0.2 story, will have a velocity of 10. And then the way this velocity helps is that in the next iteration, you are going to plan for 10 story points once again, because we are working at a sustainable pace, right? The way these points are given to you is at the end of those 2 weeks, you are going to do a very small demo with the product management team. The product management team is going to look at the code. If they are happy, they're going to say that it is this work looks good, and let's move on to picking up the next set of element from the backlog. All right, if for some reason you could not finish one of those stories, you are not going to get point for that. So in a team of five with 5 stories of 2 point each, if one person is not able to finish his story, then we are not going to count the points, and that week's velocity or that iteration's velocity is going to be 8. And then that story is going to push to the next iteration, and inside that next iteration, when we finish that story, we're going to get point in that particular iteration. So velocity is a general indication of how your team is performing compared to the planning work that you're doing, right? The next important thing of extreme programming is frequent releases. Now, what happens is programmers, they generally shy away from sharing their work with other team member, right? And extreme programming, it highly discourages this. See, if there are 5 developers, 10 developers in a team, and everybody is writing code, chances are that they're going to step on each other's toes, right? One piece of functionality that one person is working on is going to be the same functionality that somebody else also worked on, or probably they were different pieces, they were accessing the same database, and When they integrate their work, when they put their work together and release a small demo, they're going to find out that one person has undone the work of another person, probably related to source code, or one person is inserting something in the database and other person's code, other team members' code is kind of undoing the effect of or overwriting the values in the database. All right, and that's why frequent releases, they are so important. The next element of extreme programming is user story. All right, and this is the second place of overlap with another process, right? So we have picked up one thing from product management and we have made it part of the extreme programming. The extreme programming always happens against a user story, right? The next thing is collective ownership, and this is more about the overall team bonding, right? In a team setup, where there are multiple developers, you are time and again you're going to run into situations where you're going to see a piece of code that is not right, right? But then that should not be. It is not an event where you're going to start finger pointing that hey, this is not my code, somebody else has written it, right? The ownership of the team, the extreme programming, it says that it is the team, and as a team, we have collectively committed to a particular iteration to certain number of stories, and it is our ownership to make sure that the work gets delivered in a very effective way. If you see pieces of code that is not the right quality, you're going to correct them. If you find a defect as a developer, right, you are not going to wait for the QA to find it. If you see that something is going to get in the way when we do deployment, you are going to inform the DevOps person or the deployment team that, hey, we are implementing something, and for that, you are going to require a special NuGet package and artifact for that deployment to go through fine. So the ownership is not with one person or the project manager or the product owner. They are supposed to know everything. The ownership lies with everybody. If as a team member you are going to have access to information, and if you figure out, if you notice something, then you're going to flag it, and that leads to the next topic of collaboration. But then okay, let's table that. Collective ownership is an entire team working towards a common objective, and they are helping out each other, and they are also improving the quality of code, the quality of delivery, the test cases themselves, and all of that. Uh, After collective ownership, the next word is continuous integration. Continuous integration is where all the roles that we have defined so far, the developers, the QA, right, work from different developers, it is coming in together, and we are testing the application as one single unit. So continuous integration is an important piece of the extreme programming. The next in line is once again simple design from here and refactoring. So these two elements, they are also part of extreme programming, and as you are building the application, your objective should be that we we write code that is simple and easy to understand. And when that doesn't happen, that is all right, because we have a fallback cushion of refactoring. We're going to go back and we're going to improve the quality of code by applying design principles, design rules, refactoring rules, and eventually going to write code that is human readable. Uh, the last piece of extreme programming is TDD, which is test-driven development. Okay, excuse me. So in TDD, we are going to write automated test cases. So the from Monday's class, the way we have written test cases, extreme programming advocates that all the code that we write, they should be written with test cases first mindset. All right, this is where the actual work is going to happen, and this should be your general practice if you are building any application. Now, when it comes to testing, testing itself is a massive activity, right? Testing starts with something called as a user story template. A user story template is going to define these three sentences, number one to begin with, but then it is also going to design, it is also going to talk about the expectation, or they're also going to put down sentences like when do you, or from this section, how do you say that a particular user story is finished? So they are going to verify, they're going to validate that these user story template, they are going to have a definition of done inside them, right? They are all according to the format of as I want to show that structure, so that there is a template that has been identified, and it is according to this user story template that every user story in the system is being written. There is another way of testing. We have only talked about TDD so far, but then another form of testing is given, when, and then, right? So given, when, then is more of the specification testing. So as business, right, we are going to define multiple scenarios that given the intent of buying, okay, given that I have enough money in account, when I go to an ATM, then I should be able to withdraw money. Given that my account status is active, when I try to log in the application, then the application lets me see my account balance, right? So given, when, then, it is not written against test cases, it is written against product requirements. And I think I should show you given, when, then. There is a technology called SpecFlow. It lets you write specifications of an application, and let me look for some sample code for this. All right, this looks good. All right, so this is add member feature. Somebody's working on this particular story. Notice that the user story template, it kind of says here, as an administrator, I want to do something so the person can get membership of the coding club, right? Now notice the test case itself. Scenario, new member name is not blank, right? And then we're going to write three statements, given, when, and then. The user has entered Bill in the name of the field. I validated the field, and I see a message saying the name is valid. All right. Now Bill here is uh, relating to this exercise here called persona, right? The business itself is going to know that our application is getting used by multiple people, multiple entities, and those personas, they're not going to get defined in silos. They're going to put actual name for that particular application or for that particular persona. So you're going to see a lot of name in such test cases. The technology SpecFlow is over here. SpecFlow is going to give you an option of writing these test cases, and in Visual Studio you can actually right click on the statement and say generate code, and it is going to create a new class for you, and it's going to decorate it with this particular string. And in the inside you can create appropriate objects and you can write validation code. So this is another type of testing, given, when, then. Then there are acceptance test cases where uh, the application is accepted for the kind of functionality which was mentioned in the product documents. Then there is another technique called mock object. If you want to transfer money $1 million from one account to another, you're going to use a mock account instead of a real account. The overlap between extreme programming and testing is this phase here, TDD. So TDD is also part of the testing efforts. Then there is something called as unit testing. Unit testing is probably going to verify one single flow of an application, right? There are two more type of testing: explanatory testing. I'm not familiar with that, and there is usability testing. So the usage of the application, you are going to verify that from special members who have not been exposed to the application, and all of this work gets also taken care of by design thinkers and UX experts. So as the application is released, they are going to come and verify that the application is still usable. Right? I'm going to talk about one last role, one last topic for this to complete this entire picture, and then we're going to call it a day. And then that topic is the team itself. Right? The team itself is going to require multiple multiple definitions, multiple processes. The first process is called a project charter. A project charter is a beginning document, and it comes from the project management terminologies. It talks about the budget of the application, it talks about the requirement of the application at the high level, it assigns the project manager, and then the team has one goal from the extreme programming, and that is sustainable pace. All right, they should always be working at a sustainable pace. Right, when there are multiple team involved, then we don't do like one round of scrum. In bigger organizations, there will be multiple teams that are doing development on their own part of the application, right? And for handling communication between what each team is doing, there is something called as scrum of scrum, right? A team member is going to have some mood every day. Let me increase the font size a little. So each team member is going to have a specific mode, and it is the agile methodology, the DevOps technique. They insist that a team should always be the mood of the team should always be informed to the other team members. And there is a calendar type. It is called Nico Nico. So if you look at the diagram, it is a mood calendar, and it is going to look exactly like this. Right. So there are team member name, and there is one column for each day, and then there are three moods that are mentioned here. So somebody is like laughing, somebody is like indifferent, and somebody is angry. Right? Every day, the team members, they are supposed to share their mood with everybody. Right? Now you can see that Theodore has been upset like most of the week, and he was happy on Tuesday. So something good must have happened, and these sentiments, they are according to what is happening in the project. So let's assume that Theodore is a QA guy, right? And the code that has been checked in, that code was in the right quality, right? When he started testing on that code, uh, a lot of things were not building, the check-ins were wrong, something has happened. People tried to fix it, and he was okay, he was indifferent, but he wasn't very happy. Then something happened on Tuesday once again, and he was pretty upset the next 3 days, right? And then on Monday, probably the Scrum Master, the team, they decided that we are going to take a lot of effort and we are going to improve the mood of this particular person because probably our delivery quality is wrong. Sharing the mood of the team member is another extremely important aspect of the agile way of development. It's a Japanese word. It's called Nico Nico. Nico means smile. Right. The next work once again that as a team you should be doing pair programming. Right. It is very for delivering code the right quality. A team should always write code in pair because pair programming, it has a lot of advantages, like there are two minds that are working on it and you don't get siloed out, you don't get zoned out, and you are not going to do development in your own mindset, right? Another uh, thing is a team room, and and let's go ahead and search for agile team room, right? An agile team room is going to be one big silo. It's going to be one big room where all the team members are sitting. I like this picture particularly. Pretty small, but then notice how they have like big whiteboards arranged by the side. The way they are standing, they are in their daily meeting and they are all trying to answer that three question, right? Or probably something came up and this guy decided that the code that he's writing, he is going to have an impact on the QA team, it's going to have impact on the product, it's going to have an impact on the QA part as well. So this guy is trying to pass on that message, and if I want to link it back, I would point it to collective ownership, right? Because you identified something, you found out something, you're going to share your thought about that particular effort in a team room. And for that to work, you are going to be your office space, it should be divided in a location like this. Now, with the online world, it is extremely difficult, and this is where uh, you create multiple channels on your collaboration platform. So I use Microsoft Teams very heavy. Inside Microsoft Teams, you are going to create multiple channels for communicating messages to all the team member, like a general communication, development related effort, release related effort, announcement, broadcast. Probably Nico Calendar can also go and sit as one of the chart element or one of the channels on that particular team communication platform. And this is going to increase the productivity and the quality of work that you deliver. Moving on, the next piece is called retrospection. So every agile team, at the end of the iteration, they are going to circle back and they're going to talk about what went well in these 2 weeks, what did not went very well, and what should we continue doing. So the way we have three questions for running daily meeting, we have three questions for running the retrospection: what we did good, what we did not do good, and what we should continue doing. In a retrospection, everybody, very honestly, they are going to talk about their experience. And then in those meetings, we can bring up these agile Nico Nico charts, and we can probably ask Theodore in this meeting that what went wrong in the first week of the iteration that you were so upset, right? And it is in these meetings that we can decide that things that developers probably are not doing the right way and what we should be changing in our practices so that everybody is better off when they're working on these assignments, right? And this thing together forms the team part. There are a couple more topics that are still remaining. We are we're going to so this is more on the agile perspective. We're going to end our session here for today.